Good day, guys, and welcome to DST 25 Python session. So, this is the online session for those who could not make it for the in-person one, or for those who want to catch up, right? So, yeah, it's going to be a comprehensive one. So, yeah, in this lesson, we are going to have a brief discussion about Python. We are also going to talk about the various IDEs used for coding in Python, and also finally we'll talk about some fundamentals or some basics, right? Yeah, so Python is an open source programming language which is widely used for machine learning, data science, data analytics, and visualization, web development, and software development, right? It's one of the modern programming language out there, and it's very versatile and then also widely used, right? And these are some of the various popular applications which were developed with Python, right? Yes, so this shows you how powerful Python is. So yeah, Python is a high-level general-purpose interpreted programming language. Now let's tackle the bolded, attributes of Python. When we say Python is high level, it means that it is very easy to learn, right? It does not require you to understand any detail about your computer, any like the depth of your computer before you can, program in Python, right? It's user friendly and it's also very, very efficient to use since most of the codes are English based, right? And also, when you say it's a general purpose language, it means that you can use Python for many, many applications or domains, right? You can use Python in the domain of web applications. You can also use it in the field of big data applications. That's if you are dealing with, big data like these social media, companies, right? They receive big data each and every minute, or they process big data each and every day or occasionally, right? So you can also use Python in the field of data science, machine learning, and then AI and or data analysis. And these are some of the most common use of Python, right? In the field of data science, machine learning, and AI, you get some data, you process it in order to draw some meaningful conclusions from it and make some good predictions using machine learning, right, and AI, whereby you train a model to understand your data, the structure of your data, and then make some calculated decisions on the future, right? And also you can use Python for software and mobile apps, right, as displayed in the previous slide, right? So yeah, when we say Python is interpreted, meaning whenever you write a Python code, it has to be interpreted to a machine language. Remember, there was this saying that the computer does not, or there is this saying that the computer does not understand human language, right? So it only understands the computer language, and the computer language is the binary, right? Or that's the zeros and ones we have, right? So whenever you write something human to the computer, it finds it very difficult to understand. It only understands the zeros and ones easily. So you always need an interpreter, right? An interpreter is what will convert, or it's what converts your Python code line by line, right, to the machine language when you are executing your program, right? And where do we code in Python? So in order to code in Python, you need an IDE, which stands for integrated development environment. This is where you program in Python. It is the user interface, or the various ones out there are the user interface which helps you to code in Python, or which provides the avenue or the working area to code efficiently in Python, right? So the most common one we have is the Jupyter Notebook, and it is mostly used by a lot of programmers out there, right? And the meaning of Jupyter actually is three languages combined, right? The Ju means Julia, and then the Pi means Python, or the Pyth means Python or whatever. And the last one is the R, right? R. The letter R is a programming language. So Jupyter is an IDE used for one of the most common IDE used for programming in Python, right? So that's what we are going to use for this session. And let's open Jupyter. So this is the next session, right? In your search bar, just type in Anaconda prompt. Mine was already showing, right? So yes, you choose the one that comes, and then when you open it, there's this engine or terminal going to open. You wait patiently for it to load first, right? Now, this is called the prompt, right? Which was developed for Anaconda. So remember, we started the session by installing Anaconda, right? So Anaconda provides the avenue of interacting with many IDs, right? You can have the VS Code, you can have all those other popular IDs, right? So when you launch Anaconda, the app itself, you see all those IDs over there, and then you choose the one you want. But in this session, and for simplicity, right, we are going to use the Jupyter Notebook. It's not an IDE for beginners, no. And personally, I've used the Jupyter Notebook for I think I've used it to develop web apps, and then I also use it for deep learning. So just clear the thoughts of Jupyter being for beginners. No, it's very efficient to program in Jupyter. So when you open the prompt, yes, this is where you can interact or create virtual environments, right? So you'll tackle virtual environments in the future, but that's where you can, you know, exclusively install packages for specific use. So if you are doing something on deep learning, right, you need a library. That's one thing about Python. Python is open source, so that's one thing you can think about. That it's not a standalone application like MATLAB, which has all the packages installed inside. For Python, since it is open source, developers around the world came together, or people constantly develop packages which are geared towards some specific use, right? So when you develop something and then you discuss with those behind the Python company, or whatever company will be involved, then they add it to the community, right? So you install your libraries here and then you use them. It also helps you to execute scripts, right? So this is like the engine. So in this place, we just type in Jupyter Notebook, right? Mind you, if I've already had or installed any library, sorry, created any virtual environment, I would have first opened it here and then before typing in Jupyter Notebook. Let's start with this. So you wait patiently for it to load. And mind you, one thing I forgot to say is that Jupyter is a web-based application, right? Or programming IDE. So it always requires you to open in your web browser, right? So by default, mine is Google Chrome, and that's the recommended one, right? So when you open, you look for any location of your choice. I have a lot of. I choose my desktop and any folder of convenience, right? So I have. If you have none, you can just click on the new, and then you create a new notebook, right? So yeah, you wait patiently for it to load. So yes, this is our ID, the Jupyter ID, and you can see your menu bar here, your title bar. This is where you can actually name your notebook, right? So we name our own tutorial underscore on one, online one, right? And these are some of the tabs here. So there's this thing called a kernel, right? So remember I told you that Jupyter runs three languages, right? So the kernel over here is specific for Python, right? If you want to code in R, you should have installed an R kernel or something. So the kernel is what will convert whatever you are doing here into Python code, right? So it's the computational engine, right, that executes your code, right? So this is Jupyter, and that's what we are going to use for this session, right? So let's start with some basics, right? So we have this called the data types in Python, right? So under the data types, you have the numeric ones, which we have under which we have the integers, the float, and the complex number. Personally, I don't use the complex number. We mostly use the integer and the float, right? And I would explain them in the next series. We also have the dictionary. We have the boolean, right? Boolean is a logical statement, true or false. That's a boolean. We also have a set, and then we have the sequence type, right? So under the sequence type, we have the string, we have the list, we have the tuple, right? So this is a type of this the integer, right? Integer is more of from negative infinity to positive infinity, right? They are the distinct numbers we have, right? So you can have your integer from -3, -2, -1, 0, 1, 2, 3. The floats are the decimals, right? Yes, this is a float, right? And remember, we said something about the string, right? A string is any character at all, any non-numeric character, any numeric character you can have. That's a string. So if you want to type in your name, or if you want to code in your name, or if you are coding a name, you want to deal with any character, you have to include the quotation marks, meaning it becomes a string. So, for example, if I have a number, right, say 9, right, if I type in a number, its data type is a what? Is an integer, but immediately I include it or I put around it a quotation mark, it becomes a string, right? We are going to see this along the line. I want to run through this, then we start programming. We start doing some example in Jupyter, right? So for the Boolean, as I said, we have true or false, right? They are logical, can you say comparators or something? So, and it's always important to note that it is proper, like it has to start with a capital, right? So true, you start with a capital, and then false. It's not a string, it's something on its own, right? It's a vocabulary on its own, so you don't have to put around it a quotation mark. So when we use this when they are writing some um, logics, right? Remember, we have this called the logic gates. If maybe this is true and this is false, maybe this should happen. We are going to touch all those things along the line, right? So let's try these in Jupyter. Please always remember to be saving your work and Uh, you can do all of those here. It's like the normal Windows applications you've been using. So we talked about the integer, right? So let me talk about variables first, right? So yes, a variable is, you can view a variable or you can think about it as a container used for storing data. Is that right? So you can store in any data type in a variable. You just have to um, write or declare it and then assign it using the equal sign, right? So if you say in the left hand side, if you say total score is equal to 55, this means that I have assigned 55 to the variable called total score, right? If I say my school is SIIMT University College, that means I have assigned this string, right? It's a string, as said earlier, to the variable called my school. The same thing, my school, KNUST, I just have to put a string around, right? So this is the syntax for naming a variable or declaring a variable, right? So there are some rules for doing that also. You can start a variable with a letter or an underscore. You cannot start with a number, and only alphanumeric characters and underscores are allowed in a variable, right? You cannot use an at sign or something. So, and also variable is case sensitive. So if I say age is equal to 25 or 50, and that variable was lowercase, and if I want to print it out or view it somewhere or use it somewhere, and then I go and type in a capital A or something, you are going to get an error prompt if only you've not declared any other variable as age with a capital A. If you've declared it elsewhere, you would get a wrong result for a different use. So yeah, so let's start real quick. So we can say something like my age, or age is equal to, then you can mention your name, your age over there. Let's say 30, right? And your name is equal to um, John, and what attribute again? Student. Then I say something like true, right? Um, let's deal with this for now. Or height. Height. I say something like 1.82. I can't bring the meters, right? If I want to bring meters, I have to make this a string, right? But this is a float. So to run, you can click on, I've run it already. You can just click on run, the run tab, and then you press on this. The shortcut for this is Control Enter. I'm always used to, so muscle memory, right? I encourage you to use the shortcut more often, right? Control Enter, then you run. When you run, you see this. So I forgot to tell you, these are called the cells. So that's one feature, about a unique feature about Jupyter Notebook, right? It allows you to program in cells, and you can type as many. You can even program a whole script into one cell, right? I think there's no limit, but your size matters, right? So when you run, it tells you the number of times you've run that cell or you've run any other cell. So if I run E is equal to 99 over here, you see it becomes 4. If I go back, it becomes 5. You see. So those are called the cells. And these are, when you see this code tab, or when you unload this drop down over here, it tells you the status of your cell, right? Right now I'm in the code mode, right? And we will discover, or we'll discuss the other ones later, right? So yes, let's print the type of the data type of the declared variables, right? We have this simple function called a print function. You can think of it as a function used for displaying the content of any variable. Is that fine? So if I want to see what I encapsulated into my variable age, I just have to do print. It's a function. So always a function comes with a set of parentheses. Is that fine? Yes, that's a function. We are going to discuss that earlier. We are going to discuss functions later in this section, right? So when I do print and then of age, then you run control enter, you see it has displayed 30 for me, right? The same thing, I can do print name. Is that fine? I can also do the same thing for my student status. True, I'm a student, and I can do the same thing for height, right? You can either do it this way or you can do it. The print function takes a lot of arguments, right? So yes, you see, I printed about 3 different variables in the last print statement, right? So you can do this or do it one by one. That's fine. So yeah, that's the print function for you. And let's try and see the data type of the declared variables, right? So in to do that, I need a function called the type function, right? The type function displays a data type of um, a declared variable or the data type of any assigned text or any integer or anything at all. So I want to see the data type of the age variable. Is that fine? So in order to do this dynamically, I can inside a print statement, right? I can do type and then wrap type around the age or wrap the type function around the age. So it's like I'm printing the type of the variable called age. Ideally, you can do it like this, right? But because we are starting, you can put a print function around it. Always mind your brackets. Is that fine? So this tells me that my age variable is under the class of integer, right? So what if I want to do the same for name? Always remember to run. It tells me it's a string, right? If I bring an at sign over here and then run it and come over here, it's still a string. Even if I put 22 inside the quotation mark and I run it and I come down here and run it as well, it still tells me it's a string. Is that fine? So let me revert it to what we had, run it, right? So if I want to print the status of my self, I'm a student, yes, and that's true. It tells me it's a boolean, right? If I want to print the data type of my height, it tells me it's a float. Is that fine? So that's the concept of the most common data types we have. And let's continue. Right. I think I skipped some things. Just a minute. I was speaking about this, and yes, so one key feature about the programming languages we have is its or their ability of performing numerical tasks. And as we all know, or as engineers, we know that when performing some basic operation, you have to follow the board mass um, conversion, right? So we have the bracket, order, division, multiplication, addition, and subtraction. The same way when they are performing numerical operations, we have to follow this conversion, right? Yes. So uh, yes, we've spoken about this. So yeah, remember we spoke about lists. It's a data type. So lists store data in the square brackets, right? It can store any type of data, right? It is comma separated. So let's declare a list over here. Let's say you have a list of names in your class. So names, remember, it stores data in a square bracket. Is that fine? So, and I can have any type of data stored provided they are comma separated. So I can have one, I can have two, I can have 1.45, I can have John. What else can I have? You can also have a list within a list, right? You can also have a list within a list. Is that fine? And then, yes, anything at all. Maybe you can have some location, tema, right? So yes, you run it, and when you try to print the list, you see what appears. Let's see the type of data or the data type for our variable called names. It tells us it's under the class of lists. Is that fine? So one thing about lists or operating with lists is called the indexing, right? Indexing tells you the position of the various items you've passed inside your list. So I can, and then with your indexing, Python starts from zero. Python starts counting from zero, right? So my first item in my list here is I passed it as one. If I want to know the location of one, is at the position of zero. The same way, the second object here is my one. So the apparent position over here is n minus 1 in Python. So if I want to index or extract, right, um, any item over here, I need to know the unique position or index, right, which is n minus 1 apparently. Is that fine? So the conversion for indexing, you bring your variable or your list variable over here, or you type it, then you use a square bracket. Then inside your square bracket, you can pass in your position, the position of whatever you want to extract. Is that fine? So if I want to extract the first object, remember I said it starts from zero. So it gives me one over here. I could have done print, but sometimes it's not necessary. Yes. So it tells me it is one. If I want to print the fourth object, that means n minus 1, which is 3, right? It tells me it's John. If I want to print the fifth object, n minus 1, which is 4, the 4 in Python. So it gives me that, oh, there's a list, right? And mind you, when you pass in a list within a list, like the fifth object we did over here, it's called a nested list, right? Nested in the sense that you are passing a subset within a whole set. Is that okay? So sometimes you can do things the dynamic way, right? If I want to extract the last object, there are two ways of doing that. It's either I do negative indexing, right? You don't have negative zero in indexing, so it starts from negative one, which is the very last object in your list. It gives me the last object, right, as expected. If you don't want to do negative indexing, so the last but one will be obviously negative 2. If you don't want to do that, what you can do is the hard, it's not the hard way, but it's also a fun way if you want to write or exercise of fingers. So names, and then there's this function called the len function, which tells me the length of any list variable. Is that fine? So when I say len of names, it tells me that I have 6 items in my list. Is that fine? So when I put in this over here, I'm going to get a very little problem because yes, sorry, I'm getting a little error. Uh, as no, sorry. When I put in this directly, I was expecting a certain error, but I didn't get that. I passed in something. So yeah, list index out of range is that fine? Which means that remember I told you that Python starts counting from zero. So if I want the last object, which is the set object, apparently it must be n minus one, which means the fifth object. So that means I should include minus one. Sorry, I did not see that my len was containing an integer, right? So you also, as a Python programmer, you should know how to read errors, right? And that was quite unexpected. So yes, these are the two ways of indexing. Um, so yes, so aside lists, we have what we call the tuple, right? The difference between a list and a tuple is that the list starts with, that's one difference. There are actually more than one difference. So as you start with, or as you include your items in a square bracket for a tuple, so let's say names 2. For a tuple, it is encapsulated in a set of or a pair of parentheses. Is that okay? So I can just copy everything here and then paste it inside as my tuple, right? And if I try to print the type of tuple, if I try to print the type of data for this variable, to tell me class tuple. Is that fine? Yes, class tuple, right? Another difference between this, I can also index a tuple as well. So yes, one the other difference between um, lists and tuple is that for the lists, they are mutable in the sense that you can actually make changes or manipulate whatever is inside. So I can delete whatever or any specified item within the list, but that of a tuple is false, right? So if I say there's many functions out there, we have the delete and then the pop, right? So if I say something, when you're using this function, you must know the index, right? If I want to delete the maybe the third item, right, which means n minus one, two, uh, for from my list called names, right? So run it, and then when I display it, you see that my third item was supposed to be what, the float over here, which is 1.45. I've deleted it, but let's try that for our tuple, which is names 2. I'll get a nice error over here. Tuple object does not support item deletion, which means that tuples are immutable. Is that fine? And fast forward to dictionaries, I'll touch the concepts real quick. So dictionaries store data in the form of key value in a pair, like in the key value pair, right? So normally your keys are strings. Is that fine? And then your values are any data type at all you can have, right? So this displayed one over here tells you that within the dictionary, and it's always stored inside the curly bracket, right? That's the naming convention or the sequence for declaring a dictionary variable, right? So you have the string over here, and it is assigned to the value of 10. The key of B, it's assigned to the value of 20, and C, we can try one over here. Let's delete this guy. So we can see that PA is equal to, then we bring our curly bracket. Remember, I said your keys are mostly strings, and that's, yes, your keys are strings. So we can say something like so let's say Monday 1, Tuesday as 2, and something like Friday as maybe we are saying something like 4, 5, for example, right? Maybe you are planning a budget or some operation within the week, right? And if we try to print out the data type, as I said, print into bracket type, and you see something like PA, it tells you that this variable falls under the dictionary of under the class of dictionaries, right? So you can also index a dictionary as well. Well, in this case, we don't use the um, integer indexing, right? You use the key indexing. Is that fine? So if I want to index one, or I want to see what was contained in one, I have to index it with the key, right? So if I say this, it tells me that, oh, I assigned one to it, right? Let's say something like today, sorry, today, and I say something like, yes, it was true. Maybe I studied, or I went to church or something. So true, yeah, I ran it. And if I say today over here, it tells me that yes, I assigned the boolean of true to it. If I want to print, if I want to display this, it tells me that this list was assigned to the key of Friday. We are fine. So that's the concept of lists. Let me see if I'll touch this in the next one. So yes, this brings us to the end of our first lesson, and see you next time.